Hi, and welcome back to Common Core Algebra 2. This is lesson 2.4, domain and range of a function. Because functions convert values of inputs into value of outputs, it is natural to talk about the sets that represent these inputs and outputs. So the set of inputs is called the domain, and the set of outputs is called the range. Once again, if you're not familiar with these terms, it's a good idea to be able to input them into your glossary, wherever you're keeping them, whether it's on index cards or in your notebook or on an app. All right, so let's just consider a very simple domain and range of a function. So consider the function that has its inputs as the inputs being the month of the year and the outputs being the number of days in each month. Again, if you're able to annotate, it's a good idea. So that has inputs, which are the months of the year, and outputs being the number of days in each month. In this case, the number of days is a function of the month of the year. Assume this function is restricted to the non-leap years. In other words, we're not going to consider the extra day year when we have 366 days. So write in roster form the set that represents the function's domain. So roster form means that you're going to use the little squigglies. And I'm not going to write out every single month, but it's going to be January, February, March, April, May, June, July, August, September, October, November, December. We'll call this one May. So there should be 12 in your domain. So write in roster form the set that represents the range. Well, how many possible days do we have in each month? Well, 30 days has September, April, June, and November. So all the rest have 31 except for February with 28. So we have 28 days, we have 30 days, and we have 31 days. It's a little poem I remember from my younger days. So we're done with that one. Pretty easy. Exercise 2. State the range of the function f of n equals 2n plus 1 if its domain is the set 1, 3, and 5. Show the domain and range in the mapping diagram below. So they're telling us the domain is 1, 3, and 5. And also make sure to state the range of the function. Make sure you're answering the question. That's really important. So if we consider our domain, so we want to know what f of 1 is, f of 3 is, and f of 5. So f of 1 is 2 times 1 plus 1, which is equal to 2 plus 1, which is 3. F of 3 is 2 times 3 plus 1, which is 6 plus 1, which is 7. And f of 5 is 2 times 5 plus 1, which is 11. So those are our ranges, 3, 7, and 11. So it says state the range. Make sure you are very specific in saying the range is 3, 7, and 11. Moving on to exercise 3. The function y equals g of x is completely defined by the graph shown below. Answer the following questions based on this graph. Determine the minimum and maximum x values represented on this graph. Well, if we consider the minimum x's, basically what we're considering is the smallest value of x on this graph and the largest value of x on this graph or on this function. So x minimum is equal to -3, and x maximum is equal to +6. Because if you look here, 1, 2, 3, 4, 5, 6. Determine the minimum maximum y values represented by this graph. This time you're just going to consider the y's. So be careful. The y actually, let me erase this so it's easier to see. So the y's, be careful. This is the highest and this is the lowest. So 1, 2, 3, 4. So the highest occurs at 4, 1, 2, 3, 4, 5, and the lowest occurs at negative 5. So y min equals negative 5, and y max is positive 4. State the domain and the range of this function using set builder notation. Now let's see if you remember what that looks like. So the domain using set builder notation is basically using the squiggles again, but x such that, that line means such that, x falls between negative 3 and 6, x falls between it, and we put less than or equal to signs between it. We read it as negative 3 is less than or equal to x, which is less than or equal to 6, but we really understand it as x is sandwiched between negative 3 and 6 inclusive. And the range is going to be y such that y is sandwiched between negative 5 and positive 4, again, with less than or equal to signs in between. That is set builder notation. Again, I'm going to remind you to pause this, rewind it as you need to. Some functions defined with graphs or equations have domains and range that stretch out to infinity. Consider the following exercise in which a standard parabola is graphed. So the function y equals, or f of x equals, x squared minus 2x minus 3 is graphed on the grid to the right. Which of the following represent its domain and range written in interval notation? So let's just recall what interval notation means. All right, so when we have something that looks like this with hard parentheses, negative 2, 4, like up on the top, the domain, basically what that means is that x is sandwiched between negative 2 and 4 inclusively. So it includes negative 2 and negative 4. But if you were to make them soft parentheses, basically what that means is that x is still sandwiched between them, but it does not include the negative 2 or the positive 4. Make sure it's telling you it's in in interval notation, so you don't get that confused with a point. So if we take a look at which one this would be, and watch, see how on number 3 it has the infinity, that up the sideways 8 right here? That just means that it goes on in both directions to infinity. In this case right here, it means it's got a boundary on the left-hand side of negative 4, but it goes to infinity. So if you take a look at all of these choices, number 1 says it's bounded both ways, and we know that's not the case because we only have a bound here, but these y's keep going. And the same thing with the x's. The x go in both directions to infinity. So we know this can't be it. We know that this can't be it, and we know that this can't be it. So 3 is our correct answer. Pause and listen to that one more time and see if you can make sense of it. For most functions defined by an algebraic formula, the domain consists of the set of all real numbers, denoted by a bold R. When we write it, we kind of write it looking like this. Sometimes, though, there are restrictions placed on the domain of a function by the structure of its formula. 2 basic restrictions will be illustrated in the next few exercises. Exercise 5. The function f of x equals 2x plus 1 over x minus 4 has outputs given by the following calculator table. So evaluate f of 1 and f of 6 from the table. You could do it by hand if you wanted to, but f of 1 is here and f of 6 is here. So it's easy enough to say f of 1 is equal to negative 1, and f of 6 is equal to 6.5. Saves us a little bit of work. B says, why does the calculator give an error at x equals 4? Well, if we take a look at our formula, we have to think about what is not allowed in this situation. Well, division by 0 is never allowed. So when you have x minus 4 being in your denominator, we know that that can never equal 0. Well, for what value does it equal 0? Well, if you add 4 to both sides, x is equal to 4. And you might have been able to get that just by looking at it. So basically, why this is giving you an error here is because it's not allowed. So it says explain. This is where you would use your words to explain what we just talked about. Because division by 0 is not allowed anywhere in mathematics. Therefore, for the value of 4, x equals 4, it would make the function undefined. And therefore, you have an error at x equals 4. And exercise 6. Which of the following values of x would not be in the domain of the function, and explain your answer? Similarly, we do have a restriction here. So y equals the square root of x plus 4. Well, hopefully you remember that you cannot have a negative underneath that radical, especially when you're graphing. So when you consider this same situation, we have to make sure that x plus 4 has to stay greater than or equal to 0. That's the only way this function is going to be defined. So if we subtract 4 from both sides, that means that x must be greater than or equal to negative 4 in order to be defined. So which of these numbers does not fit in this restriction? So x has to be greater than or equal to negative 4. This is greater than negative 4. 5 is greater than negative 4. Negative 3 is greater than negative 4. Think about that number line. And this is the only one that is not. It falls to the left of the number line of negative 4. You can check it also by giving it a quick check. Square root of negative 8 plus 4 is equal to the square root of negative 4, which is not defined. So at this point, we're done. We are finished with 2.4. Make sure you take a look at this one more time if you need to. We're going to spend some time tomorrow going over some classwork problems. And until then, remember, only you can make your own destiny. Okay? See you next time.